Hello, teachers. Welcome to the last of 3 parts of section 1.1, problem solving. Let me remind you of the 4-step problem solving process. First, we always want to understand the problem thoroughly. Don't try to jump into devising a plan until you really know you understand the problem. Second, let's devise a plan to solve the problem. Then, of course, we need to carry out the plan, being very careful to use accurate mathematical rules, write all of your work down, and be sure to stay on task. And finally, looking back to kind of summarize what we did, check our answers if possible, and make sure our answer is reasonable. Okay, so let's solve just a few more problems working with some of these strategies that we've talked about. Do you remember this strategy, guess and check? First, guess at a solution using a reasonable guess as possible. Then check to see whether the guess is correct. The next step is to learn as much as possible about the solution based on the guess before making a next guess. This strategy is often used when a student does not have the tools to solve the problem in a faster way. It's primarily used by students in grades 1 through 3, but hey, we all use guess and check. Something that reminds me of guess and check is when you're doing long division. Maybe it's been a while since you've done long division, especially when you have a 2-digit divisor. And you have to kind of play around with how many times, say, 23 might divide into 97. You know what I mean? You can come up with a good guess, but you really just have to go to the side and multiply it out to figure out what that quotient is. And so that's an example of guess and check, but there's lots of options to use guess and check. Another strategy is write an equation. You know, even though algebraic thinking is involved in the strategy writing an equation and may evoke thoughts of traditional algebra, you know, X, a closer look reveals that algebraic thinking starts very early in students' school lives. I don't know if you've been close to any students, say in the 1st grade, but they're already working with problems that look just like this, or maybe 2 plus box equals 9. What goes in the box? And so this builds algebraic thinking from a very young age. Here we have a problem that says, find the subtrahend in a problem like the following. So 14 minus what equals 3? And really, this is algebraic. We know the answer is 11, but even some guess and check strategies would come into play here. If you were very young in doing this, you would just play around and plug in numbers and just see what works. But writing an equation is a great way to solve a problem when it applies. And then I've got really just one more extra practice problem I'd like to do with you to help you out with the homework. Okay, so our last example from section 1.1 problem solving. If 5 people shake hands with one another exactly once, how many handshakes take place? What about how many handshakes for N people? Okay, so first we just want to do this with 5 people, and then maybe make a rule where we could figure out the number of handshakes no matter how many people you use. So first, you know what we need to do? We need to understand the problem. So what is the problem here really? Well, we're taking 5 people, and they each need to shake hands with one another. Now, I've drawn a diagram for this before in the past. So I'm going to use 5 people just as dots, and I'm going to kind of put them in a circle. So I'm going to say, you know, you got 1, 2, 3, 4, 5 people, right? And they're going to shake hands with each other, one at a time, of course. You don't want to reshake anybody's hand. And so let's just count, and I'm going to draw lines to represent a handshake. So there's 1 handshake, 2 handshakes, 3 handshakes, 4 handshakes, right? I'm just going to put that, there's 4 of those handshakes. And this is just one person represented. So this is you. right? And you've got to shake your hands with 4 other people. All right, now let's move on to your buddy over here. All right, I'm going to change colors. Now, I'm not going to do this handshake from, your buddy back to you, right? We've already done that one. But your buddy hasn't shaken this person's hand, or this person's hand, or this person's hand, right? So that's plus 3 more handshakes. All right, now what about the person on the other side of that person? Let's let this be our green person. Now, I'm not going to draw, because so you see I'm right here. I'm not going to draw to where the pink handshake is, okay? I'm also not going to draw where the purple handshake is, because that's already happened. But the green person hasn't shaken hands with this person and with this person. But all the other 2 have been done. So I'm going to add 2 to that. Are we finished? No, it looks like we don't have a handshake right here. So my final handshake, I'm going to do in, what have I not used? Blue, okay? Final handshake right here, that's the one missing handshake, and plus 1. So how many handshakes is that total? If I add those together, you're ahead of me on this already. Got 4 plus 3 is 7, plus 2 is 9, plus 1 more is 10 handshakes. Always be sure to use units, and in this case our units is handshakes, and encourage your students to always use units as well. That's super important in a math class. So we've got 10 handshakes. Does that seem like a reasonable plan to you? Okay, when we take a look back, could we extend this to N people? How could we do this? Now, notice with 5 people, the first number of handshakes was with 4 other people, right? And then it was with 3 people when you move to another person, then with 2 people, and then with 1 person. So if you're talking about N people, you would take N minus 1, right? Because if there was 5, my first number I added was 4. Let me do this in a different color. Let's keep our colors. I like all those colors anyway, right? So our 4 compares to N minus 1 when you're dealing with N, right? Because 5 minus 1 is 4, so N minus 1, however, if we had 10 people, it would be 9. If you had 100 people, it would be 99, okay? Plus, now the next number, see if you agree with me here, if it was, if you started with 10, it'd be 9 plus 8. Well, if you start with N, the first one's N minus 1, what would the next number be? How about N minus 2, right? Okay. And then what would the next number be? How about N minus 3? And you keep going down, right, until you get to only 1 handshake left. Okay? Now, this is a formula, but it's not simplified. Turns out that will simplify a lot. So our goal is to write this N minus 1 plus N minus 2 plus N minus 3 plus 1 in a more simplified form. Although this is correct. This would be N handshakes. So let's see if we can write it in a more simplified form, which gets a little bit complex, but hang with me. Okay, so let's rewrite what we've got. We've got, remember, we're doing N minus 1 plus N minus 2 plus N minus 3. Really all the way until we get to, we could get away with this, to N minus N, right? What is N minus N? That is just 0. Then if you do N minus 1 right before that, that would give you that 1 that I had before, remember? So if we're trying to simplify this is what I want you to think about. If you can regroup, and we're going to talk about what this rule is later on in the semester, but we can regroup to these. What if we put all of our N's together? Now what we want to do is group together our N values, okay, and then group together our numerical values. Can we do that? Yes, we can regroup. It's actually called the commutative property of addition. All right, so let's group together those N values. So that would be, so make sure my pen's working, N plus this n plus this n plus this n plus we keep going all the way till we get to this n. Okay, I'm going to group those together. All right, plus this is -1 plus -2 plus all the way to -n. Okay, now how many n's do we have right here? Well, there's actually n of them, right? Because we started with n all the way, counting from 1 all the way down to -n. That's n of these. So there are n n's. Hang with me. All right, now over here, every one of these is negative, right? -1, -2, -3, all the way to -n. I'm going to factor out that negative, so it's going to be a minus. Then all those turn positive. So 1 plus 2 plus 3 all the way to n. Okay? Now, n times n we know is n squared. Now, from Gauss, okay, so from the very first video where we talked about Gauss's problem, remember I gave you a cute formula to do this. Remember, it's the number of terms you have. If you start at 1 and you don't skip any numbers and you go all the way to n, that is n terms, okay? And then you do your first plus your last, right? That's 1 plus n. I'm going to write it as n plus 1, okay? And then you divide by 2. Remember, the reason we divided by 2 is because when Gauss did it, he added the series together twice. And then we have to divide by 2 to fix it. Now, there's some algebra that goes along with simplifying what we've got going on here. The first thing I want to do is I want to add these together. I can't without a common denominator, so watch this. I'm going to multiply by 2 over 2 right here. Now I have a common denominator of 2. Next thing, I'm going to write this as a single fraction. So this is 2n squared minus n times n plus 1 divided by 2. Now here's what I want you to notice. I'm going to go to another page to do this. I'm going to factor out this common n. Okay, so when I pull that out, I'm going to get an end. Remember, we're pulling out that common n. Okay, so I'm pulling this out. What is that going to leave me with? So first of all, some parentheses. The 2 and one of those n's is still there. Remember, n times 2n would give me 2n squared. Okay, now this n is also out front. So minus n plus 1. And that's over 2. So that the aqua n, I just pulled that out. That left me with a 2n here, and then an n plus 1. Now, you know your algebra steps. Next thing I have to do is distribute this negative inside the parentheses. So this negative has to go into both of those. Again, don't panic. So this is going to be minus n minus 1. That's all over 2. Now, you know the drill. I need to add my like terms. So this 2n minus 1n is just n. So that gives me the n out front is still here. I'm writing that now. And then when I add like terms and I combine those together, that gives me n minus 1 over 2. And that is the same thing as n minus 1 plus n minus 2 plus n minus 3 all the way down to 1. So that's an equivalent and a much easier formula to use. So if you had 50 people that needed to handshake with other people, how many handshakes would that be? It would be 50 times 49 divided by 2. It's neat, huh? We proved a formula right here. We took a basic problem with 5 people shaking hands. We extended it to just any number of people shaking hands, and we developed a formula that would work for all those situations. Now, don't panic. I know this is not an easy thing to do right here, but just make sure you can follow me, and you'll be okay. Okay, so I hope this first section went well. Be patient with yourself. This is going to be just fine. Okay, have a great day.